Today's session, the first term is we have conjugate of complex number. We have conjugate of complex number. It means, suppose we have a complex number z like x plus iota y. We have a complex number like x plus iota y. So if you want to represent on Argand plane, then this will be look like this, x plus iota y. It means horizontal movement in positive real axis and the vertical movement in positive imaginary axis. Now if we take the mirror image of this point, now if you want to take the mirror image of this point about the real axis, then we have x minus of iota y. If you take the mirror image of this complex number about the real axis, then we have x minus of iota y. So this complex number is called the conjugate of this complex number. It means, suppose if we have a z is equal to x plus iota y, if we take the mirror image of this complex number about the x-axis, then it is called as conjugate of complex number. It means conjugate of complex number is equals to x minus of iota y. If we have z is equals to x plus iota y, then conjugate of z will definitely equals to x minus of iota y. Now if we add these two terms, it means z plus conjugate of z, then it will be equals to 2x. It means if we divide it by 2, then this term will be equals to x. X means real part of z. If we add z with conjugate of z and divide it by 2, then we have z plus conjugate of z divided by 2, which is equals to x. X means real part of x. Then after, if we subtract these two equations, it means z minus conjugate of z, then we have 2 times of iota y. Now if we divide by 2 iota, then we have imaginary part of z. If we add z with conjugate of z, then we have 2x. Now if we divide by 2, then we have z plus conjugate of z divided by 2, that will be equals to x. X means real part of x. Then after, if we subtract these two terms, then we have z minus conjugate of z divided by 2 iota. That term will be equals to imaginary part of z. Now we can clearly say that if z minus conjugate of z is equals to 0, if z minus conjugate of z is equals to 0, then that term will equals to 0. If this term is equals to 0, it means imaginary part of z is equals to 0. Then we can conclude this as z will be purely real number. Z will be purely real numbers. If we have a condition like z minus conjugate of z is equal to 0, it means this term is equals to 0. It means imaginary part of z is equal to 0. Now we can conclude this as z will be a purely real number. And if we have z plus conjugate of z is equals to 0, it means this term is equals to 0, or you can say real part of z is equals to 0. If real part of z is equals to 0, then we can say z will be purely imaginary number. If z minus conjugate of z is equals to 0, then z will be a purely real. If z plus conjugate of z is equal to 0, then z will be a purely imaginary number. Then after, as we all know that z is equal to x plus iota y and conjugate of z is equal to x minus of iota y, it means if we multiply by these two terms, then we have x plus iota y and multiply by x minus of iota y. So a plus b, a minus of b, that term will be equals to a square minus of b square. It means x square plus y square, which is equals to mod of z square. As we all know that mod of z is equals to square root of x square plus y square. If we square this term, then we have x square plus y square. So now we can clearly say that z multiplied by conjugate of z is equals to mod of z square. Now here is a one very important term is if mod of z is equals to 1. If mod of z is equals to 1, then we can say z multiplied by conjugate of z is equals to 1, or you can say z will be 1 upon conjugate of z, or conjugate of z will be 1 upon z. Z will be conjugate 1 upon conjugate of z, and conjugate of z will be 1 upon z. If we have mod of z as 1, it means z multiplied by conjugate of z is equals to 1. If z multiplied by conjugate of z is equals to 1, then we can say z will be equals to 1 upon conjugate of z, or conjugate of z will be equals to 1 upon z. So in any question, if we have mod of z is equals to 1 directly or indirectly, it means we just need to replace z by 1 upon conjugate of z, or you can say conjugate of z by 1 upon z. Now we have, if we want to take the conjugate of z1 upon z2, if you want to take the conjugate of z1 upon z2, so that term will be equals to conjugate of z1 upon conjugate of z2. Or if you want to take the conjugate of z1 multiplied by z2, so that will be also equals to conjugate of z1 multiplied by conjugate of z2. Or you can say, if you want to take the conjugate of z to the power n, so that term will be equals to conjugate of z whole to the power n, and then after if you have z1 plus z2 and whole ka conjugate, that term will be equals to conjugate of z1 plus conjugate of z2. So guys, please note it down, or if you have any kind of doubt, query related to this term, you can ask. Praful beta, window for your exam will be open from 10 a.m. to 8 p.m. You can select any 3 hours. Guys, please concentrate on this term, conjugate of complex number. If you have any kind of doubt or query related to these terms, you can ask. If you have any kind of doubt or query related to the conjugate of z, you can ask. But in the ninth term, we just have conjugate of z to the power n. We just have conjugate of z to the power n. Yeah, in the ninth term we have conjugate of z to the power n, that will definitely equals to conjugate of z and whole to the power n. Guys, now is it clear? Aditya beta, now concentrate on conjugate of complex number. Sixth one. But it's a very important property. If mod of z is equals to 1, it means this term will be equals to 1. 1 square is also equals to 1. Then we can clearly say that z multiplied by conjugate of z is equals to 1. Now if z multiplied by conjugate of z is equals to 1, now we can conclude this as z will be 1 upon conjugate of z, or you can say conjugate of z will be 1 upon z. Because beta, if we multiply by z with conjugate of z, if you multiply z with conjugate of z, then we have x plus iota y multiply by x minus of iota y, a plus b, a minus b, that will be equals to a square minus of b square. It means x square plus y square. Square of iota y is equals to minus of y square. So x square, a square minus b square will be equals to x square plus y square. Guys, is it clear? Or if you have any doubt, any kind of doubt or query, you can ask. If you have any kind of doubt or query, you can ask. Okay, all right. So after this, we have argument of complex number. Or you can say amplitude of complex number. Amplitude of complex number. So guys, please listen very carefully. It's quite confusing. So suppose we have for the argument of complex number, we have two terms. First one is principal argument and the general argument. First one is principal argument and the second one is general argument. So if you want to talk about the principal argument, then we can say that our principal argument of z is always greater than minus of pi and less than and equal to plus pi. यानी माइनस पाई से बड़ा होगा और पाई या पाई से छोटा होगा. Argument, principal argument of z is always lies in between open interval of minus pi to close interval of pi. But general argument of if you want to calculate the general argument of z, then it may be less than minus of pi or greater than pi. So now suppose we have a complex number z, x plus iota y. Suppose we have a complex number z which is x plus iota y. If you mark this complex number in the argand plane, then we have this term as x plus iota y. So basically, if we join this point with the origin, then this line, then angle with the positive x-axis in anti-clockwise direction. So then the angle with the positive x-axis in the anti-clockwise direction is called the argument of z. Angle with positive real axis in anti-clockwise direction is called argument of z. So now we have four terms. If we just want argument of z lies in between minus pi to plus pi, it means we have four terms. In the first quadrant we have theta, because already in the first quadrant theta lies in between 0 to pi by 2. In the second quadrant we have pi minus of theta. Or you can say in anti-clockwise direction is if angles are positive, then in clockwise direction angles will be negative. So if in the first quadrant we have a theta, so in the fourth quadrant we have minus of theta. In the second quadrant we have pi minus of theta. It means in the third quadrant we have minus pi plus theta. Now let's see what's the meaning of theta, pi minus theta, minus of theta and minus pi plus theta. Suppose we have a complex number like z is equals to 1 plus iota, then after we have z is equal to minus 1 plus iota, then after we have z is equal to 1 minus of iota, and then after we have z is equals to minus 1 minus of iota. In the first question we have z as 1 plus iota, in the second question we have z as minus of 1 plus iota, in the third question we have 1 minus of iota, or in the fourth one we have minus 1 minus of iota. Now if you want to calculate the argument of all these complex number, for the first one, first you just need to write, as we can clearly say that this term will be equals to x, this term will be equals to y. So tan theta will be equals to y upon x. tan theta will be equals to y upon x. So in the first term we can clearly say that tan theta will be equals to 1 upon 1, it means 1. So now theta will be equals to pi by 4. Now theta will be equals to pi by 4. In the second term we can we should consider this negative minus of 1 as plus 1. So again tan theta is equals to 1 upon 1. So theta is equals to pi by 4. In the third one, again tan theta is equals to 1 by 1, so the theta will be pi by 4. Or in the fourth one, again tan theta is equals to 1 upon 1, it means theta is equals to pi by 4. It means we just need to consider positive real axis as well as negative real axis. Or you can say we just need to consider value of real axis as positive and the value of imaginary term is also positive. In the second term we have real term as minus 1, but we just need to consider as plus 1. Then after imaginary term as 1, so it is already a positive. In the third one we have real term as 1, but the imaginary factor is minus of 1. Now if we take the positive term, then we have a plus 1. So again tan theta is equal to 1 by 1. In the fourth one also tan theta is equal to 1 by 1. Now you just need to check whether this complex number lies in the first quadrant, second quadrant, third quadrant or fourth quadrant. We can clearly say that in this complex number we have real part as positive, imaginary part is also positive. It means this complex number lies in the first quadrant, so the argument of z will be equals to theta. Now answer will be pi by 4. Argument of z will be equals to pi by 4. For the general argument we can also say this as argument of z will be equals to pi by 4 plus 2n pi, where n belongs to any integer. Pi by 4 plus 2n pi, where n belongs to an integer. Suppose this complex number lies at this point. Now if we rotate this complex number for 2 pi angle, then again we have z is equal to x plus iota y. Again if we rotate this complex number for 2 pi angle in anti-clockwise direction, then again we have z is equals to x plus iota y. So the principal argument will be equals to pi by 4. For the general argument we have pi by 4 plus 2n pi. In the second term, let's check this complex number lies in which quadrant. So we have x as negative, or you can say real part as negative, but the imaginary part is positive. So this complex number lies in the second quadrant. Because real part is negative but the imaginary part is positive, so we can say argument of z, or you can say principal argument of z will be equals to pi minus of theta. It means pi minus pi by 4, which is equals to 3 pi by 4. In the second quadrant, argument of z will definitely equals to pi minus of theta, where theta is equals to pi by 4. It means principal argument of z will be equals to pi minus of pi by 4, which is equals to 3 pi by 4. Now if you want to calculate the general argument, so the general argument will be equals to 2n pi plus 3 pi by 4. 2n pi plus 3 pi by 4 in this term where n belongs to any integers. So now if we proceed for the third one, then we have 1 minus of iota, 1 minus of iota, 1 as real part minus of 1 as imaginary part. So now real part is positive but the imaginary part is negative. It means z lies on the fourth quadrant, so the argument of z will be equals to minus of pi by 4. Because in the fourth quadrant we have minus of theta, it means argument of z will be equals to minus of pi by 4. Or if you want to calculate the principal argument of z, then it will be equals to 2n pi minus pi by 4. Now in the fourth one we have x as negative, y as also negative, or you can say real part is negative, imaginary part is also negative. It means argument of z, or you can say principal argument of z will definitely equals to minus pi plus theta. It means minus pi plus pi by 4. This will be equals to minus 3 pi by 4. Again if you want to calculate the general argument, then we have minus 3 pi by 4 plus 2n pi. Guys, is it clear for all? Or if you have any kind of doubt or query, you can ask. If you have any kind of doubt or query related to these terms, you can ask. Guys, is it clear for all? Okay, Kunal beta, in the fourth part we have z as -1 minus of iota. It means x is negative, or you can say real part is negative and imaginary part is also negative. It means z lies on the third quadrant. In the third quadrant we have minus of pi plus theta. It means argument of z will be equals to minus pi plus pi by 4. This will be equals to minus of 3 pi by 4. If you want to talk about general argument of z, then it will be equals to 2 pi minus of 3 pi by 4. Now Kunal, is it clear? Okay, all right. So after this we have some properties of argument of z as similar to properties of logarithmic function. We have some properties of argument of z as similar to some properties of logarithmic function, or so now the first term is if we have argument of z1 multiplied by z2. If we have argument of z1 multiplied by z2, that will definitely equals to argument of z1 plus argument of z2 plus 2 pi. This 2 pi for the general argument, or you can say for the principal argument. Suppose if we add argument of z1 plus argument of z2, and then we have a value as 5 pi by 2, which is greater than pi. So now we just need to subtract from 5 pi by 2, we just need to subtract even multiple of pi from 5 pi by 2. So for example, if we have argument of z1 plus argument of z2 as 5 pi by 2, so 5 pi by 2 is a general argument, but we just want, if we just want principal argument, then principal argument will be equals to 5 pi by 2 minus of 2 pi. Or you can say if we have a 7 pi by 2, then we just need to subtract even multiple of pi according to the value. So if we have a 7 pi by 2, then we just need to subtract 4 pi and so on. So this 2 pi is for principal argument, or we can say general argument. Now if we have argument of z1 upon z2, which is equals to argument of z1 minus argument of z2 plus 2 pi. Again, this 2 pi is for principal argument, or you can say general argument. Then after, if we have argument of z to the power n, this term will definitely equals to n times of argument of z plus 2 pi. And then after, if we have argument of z as theta, if we have argument of z as theta, then argument of conjugate of z definitely equals to minus of theta, because for the conjugate of z we just need to take mirror image about x-axis. If we take mirror image about x-axis, then angle will be in clockwise direction. If this angle is in anti-clockwise direction, then for the argument of conjugate of z, angle will be in anti-clockwise direction. So argument of conjugate of z will be equals to minus of theta. We can also understand this term from this diagram. Suppose we have a z and this angle is theta. Now if we take conjugate of z, it means mirror image about the x-axis, then we can clearly say that for this term, this angle will be in clockwise direction. So the argument of conjugate of z will definitely equals to minus of theta. Then after, suppose we have argument of iota, or you can say argument of any positive purely imaginary number, or you can say argument of any positive purely imaginary number is pi by 2, because iota lies on this term, on the iota lies on y-axis. Now if you calculate this angle, then that angle will be equals to pi by 2. So the argument of iota is equal to pi by 2, or you can also conclude this as argument of any positive purely imaginary number is equals to pi by 2. Now if we have argument of minus of iota, it means minus of iota lies on the negative y-axis. Now if we calculate this angle, then that angle will be pi by 2 in clockwise direction. So now we can say answer will be minus of pi by 2, or we can also conclude this as argument of negative purely imaginary number is always equals to minus pi by 2. Now if you want to calculate the argument of 1, or you can say argument of any positive real numbers, so any positive real numbers lies on this x-axis. If we calculate the angle from positive real axis in anti-clockwise direction, then it will definitely equals to 0. So we can say argument of any positive purely real number is equals to 0. But if we have a purely real number as negative, or you can say if we have argument of minus 1, this will definitely equals to plus pi. Suppose z lies on this term on negative x-axis. If you want to calculate this angle, then that angle will be equals to pi, or you can also conclude this term as argument of any negative purely real number is definitely equals to pi. Argument of any negative real number is definitely equals to pi. Guys, please note it down, or if you have any kind of doubt or query, you can ask. If you have any kind of doubt or query related to this term, you can ask. आदित्य बेटा 7th वाले में हमारे पास है पॉजिटिव रियल नंबर, और अगर मैं पॉजिटिव रियल नंबर की बात करूंगा तो वो पॉजिटिव रियल एक्सिस के ऊपर लाई करेगा. अब चेक करो ये कितना एंगल बना रहा है, तो ये 0 एंगल बना रहा है, तो आंसर विल बी 0. आर्ग्यूमेंट ऑफ 1 विल डेफिनेटली इक्वल्स टू 0. हाँ, कुणाल एंड आदित्य, अब समझ आ गया हमें. Tirupati, in the 5th one we have argument of iota. In the 5th one we have argument of iota. Iota is purely imaginary number, and we can also say that this point lies on the here. If you mark the iota on the argand plane, then we have 0, 1. Now if you calculate the angle from positive real axis on the anti-clockwise direction, then we have pi by 2. So argument of iota is equals to pi by 2. Tirupati, is it clear? And similarly, argument of minus iota, we can clearly say that it will be lies on negative y-axis. Negative y-axis means if we calculate the angle from positive real axis in clockwise direction, that will be equals to pi by 2. So the answer will be minus of pi by 2. Yeah, Praful beta, argument of 5 is also equals to 0. Argument of 5 is also equals to 0. Tirupati, now is it clear? Tirupati, now is it clear? Okay, all right. So after this we have some terms related to the locus. So guys, please listen very carefully and try to link all this term. So suppose we have z. Z means x plus iota y, or you can say a variable point. Locus means what's the meaning of locus? Basically, locus is path followed by a point. Locus is path followed by a point. एक point जिस path को follow करेगा, this path is called as a locus. So in this term we have z as a variable point, or you can say z as a moving point, x plus iota y, and the remaining terms will be constant, fixed point, or you can say fixed points. Remaining terms will be a fixed points. So suppose we have first term as argument of z minus z1 upon z minus of z2. Argument of z minus z1 upon z minus of z2. In this term we have z, z1 and z2. Z is a fixed point, z is a moving point, but z1 and z2 are the fixed points. Z is a moving point, but z1 and z2 are the fixed point. In the first term we have argument of z minus of z1 upon z minus of z2. We have argument of z minus z1 upon z minus of z2. In this term, we have z as a fixed point, and z1 and z2, we have z as a moving point, but z1 and z2 are the fixed point. So we have different possibilities. It may be equals to 0, it may be equals to pi by 2, it may be equals to 0, it may be equals to pi, or you can say it may be equals to pi by 2, or you can say it may be equals to any other angle from 0, pi and pi by 2. So if this term is equals to 0, then we can also write this term as argument of z minus of z1 minus argument of z minus of z2. It means the angle between these two terms is equals to 0. Is it only possible if this is a straight line? यानी ये एक straight line होगा तभी ये possible है. So it means if argument of z minus z1 upon z minus of z2 is equals to 0, then we can conclude this as locus of this point will be straight line. Now we have a pi. Pi means now again we can clearly say that this is only possible if it's a straight line. So now again it's straight line. It means z, z1 and z2, all these 3 points are collinear, or you can say all these 3 points lies on a straight line. Now we have a pi by 2. As we all know that in a circle, if we have z1 and z2 as ends of diameter, if we have z1 and z2 as end of diameter, if we join z1 and z2 with any point which lies on circumference of circle, then this angle will definitely equals to 90 degree, or you can say pi by 2. Now if you move this point in the right hand direction or left hand direction, then angle remains same and it is always equals to pi by 2. So we can clearly say that if argument of z minus z1 upon z minus z2 is equals to pi by 2, then it's a circle where z1 and z2 are ends of diameter. Now we have argument of z minus z1 upon z minus of z2 as theta. It means now we can clearly say that in any circle, if we have z1 and z2 on the minor arc, or you can say on major arc, now if we join these 2 points with any points which lies on circumference, then this angle will always remains constant. We can clearly say that if this is theta, then this angle is also equals to theta. So now we can clearly say that if argument of z minus z1 upon z minus z2 is equals to theta, then locus will be circle, where z1 and z2 are the ends of major arc, or you can say a minor arc. Or if you want to write this or clearly, then we can also say that the locus will be major arc or minor arc. Major arc or minor arc. So guys, if you have argument of z minus z1 upon z minus z2 is equals to 0, then the locus will be straight line. Is equals to pi, locus will be straight line. Is equals to pi by 2, locus will be circle, whose diametric ends are z1 and z2. And if it is equals to theta, then the locus again equals to circle, or you can clearly say that major arc or minor arc, not complete circle. Guys, is it clear for all? Please, if is it clear, then please note it down. If is it clear, then please note it down. Or if you have any kind of doubt or query, you can ask. If you have any kind of doubt or query, you can ask. Okay, Tirupati, but you just need to remember. If we have a term like argument of z minus z1 upon z minus z2 is equals to 0, then locus of this point z will be straight line. If is it equals to pi, then the locus will again straight line. Or you can also say that then after z, z1 and z2 all are collinear points. If we have angle as pi by 2, then we can clearly say that this will be a circle. This will be a circle where z1 and z2 are the diametric ends, because according in the circle, if we have z1 and z2 are the diametric ends, then if we join these 2 points with any point which lies on the circle, then this angle is always equals to pi by 2. And we just want angle between z minus z2 and the z minus of z1 is equals to pi by 2. So we can clearly say that if this term is equals to pi by 2, then the locus will be circle whose diametric ends are z1 and z2. If this term is equals to theta, then we can again say that locus of this point is equals to circle. Aryan beta, basically locus is a path followed by a point. It means if this term is equals to pi by 2, then z can move on this path. So we can conclude this as locus of z is equals to circle. So after this we can conclude this as locus of z is equals to circle. आदित्य बेटा, यहां पे मेरे पास z है. सपोज क्वेश्चन हमारे पास लिखा हुआ हो फाइंड द लोकस ऑफ आर्ग्यूमेंट ऑफ z माइनस z1 अपॉन z माइनस ऑफ z2 इज इक्वल्स टू पाई बाय 2. इसका मतलब है हमें उस z पॉइंट को मूव कराना है, और ऐसे मूव कराना है कि इन दोनों के आर्ग्यूमेंट का डिफरेंस हमेशा पाई बाय 2 के इक्वल बन जाए. Guys, is it clear for all? Or if you have any kind of doubt or queries related to this term, you can ask. Otherwise, please everyone give me a permission to proceed for the next concept. Otherwise, please everyone give me a permission to proceed for the next concept. Yeah, but if we have a argument difference between these argument as theta, then we have a circle, or suppose z1 and z2 lies on the z1 and z2 are these points. Now if we join any point which lies on this curve arc, then this angle will definitely always equals to theta. Tirupati beta, now is it clear? Tirupati, now is it clear? Okay, all right. So after this we have modulus of complex number. We have modulus of complex number. So guys, suppose we have a z as complex number x plus iota y. So we can also represent this as mod of z. Now if we write this mod of z, Tirupati, if theta is equals to pi by 2, then z1 and z2 will be the ends of diameter. But if these points are ends of major arc, or you can say minor arc, then theta may be equals to maybe acute angle or maybe obtuse angle. If theta is only equals to pi by 2, then z1 and z2 will becomes ends of diameter. Okay, alright. So guys, if we have a z as x plus iota y and we just want to calculate mod of z, so we can also write this term as mod of z minus of 0. We can also write this term as mod of z minus 0. Now we can also conclude this term as distance between z and the origin. Distance between z and the origin, if you mark the point x plus iota y. If you mark the point x plus iota y, and now if you want to calculate the distance from origin, then this distance will definitely equals to square root of x square plus y square. Simple distance formula, square root of x2 minus x1 square plus y2 minus y1 square. That term will definitely equals to square root of x square plus y square. Now suppose we have mod of z1 minus of z2. Suppose we have mod of z1 minus of z2, where z1 is equal to x1 plus iota y1, z2 is equal to x2 plus iota y2. If we want to calculate the distance between these two terms, then we can clearly say that square root of x2 minus x1 square plus y2 minus y1 square. So now we can simply link this modulus with the distance. So if we have mod of z means distance between origin and z. Or if you have mod of z1 minus of z2, then we can say distance between z1 and z2. So simply if you want to calculate mod of z1 minus z2, that term will definitely equals to square root of x2 minus x1 square plus y2 minus y1 square. After this we have some properties of modulus. Suppose we have mod of z1 multiplied by z2. This term will definitely equals to mod of z1 multiplied by mod of z2. Then after, if we have mod of z1 upon z2, this will be equals to mod of z1 upon mod of z2. Or if we have mod of z to the power n, this will be equals to mod of z and whole to the power n. And if we have, after this, if we have mod of z1 plus z2 and whole to the power 2. If we have mod of z1 plus z2 and whole to the power 2, this will definitely equals to mod of z1 square plus mod of z2 square plus 2 times of real part of z1 into conjugate of z2. Or you can say mod of z1 square plus mod of z2 square plus 2 times of mod of z1 mod of z2 multiplied by cos theta, where theta is angle between z1 and z2. Where theta is angle between z1 and z2. Similarly, if we have a negative sign, then we also have negative sign, and again we have negative sign. So if you want the proof of the fourth property, then I can post on your Telegram group. But my suggestion is just remember mod of z1 plus z2 whole square. This term will definitely equals to mod of z1 square plus mod of z2 square plus minus 2 times of real part of z1 into conjugate of z2, and we can also write this term as mod of z1 square plus mod of z2 square plus 2 times of real part 2 times of mod of z1 mod of z2 multiplied by cos theta. Guys, please note it down. Or if you have any kind of doubt or query, you can ask. If you have any kind of doubt or query, you can ask. Okay, all right. So after this, yeah, Kunal, I will post the complete proof on this Telegram group. I should be that theta is angle between Z1 and Z2. Theta is angle between Z1 and Z2. So yeah, or you can simply you can simply say that theta will be argument of Z1 minus argument of Z2. Okay, all right, guys. So after this, we have one triangular inequalities. We have one triangular inequalities, or you can say, if we have a mod of Z1 plus or minus of Z2. So simply, as we all know that sum of two sides is always greater than to the third side, and difference between two sides is always less than to the third side, but we just want a positive quantity. It means mod of Z1 minus mod of Z2 is always less than and equal to mod of Z1 plus minus of Z2 is always less than equal to mod of Z1 plus mod of Z2. Guys, please note it down, this property. It is called as triangular inequality. Sum of two sides is always greater than to the third side. Difference between two sides is always less than to the third side. After this, we have one very good question related to all these term modulus, argument. So if we have mod of Z1 is equals to 2, if we have mod of Z1 is equal to 2, mod of Z2 is equals to 3, and mod of Z3 is equals to 4. If we have mod of Z1 is equal to 2, mod of Z2 is equal to 3, and mod of Z3 is equals to 4, and 2 times of plus 3 times of plus 4 times of Z3, and mod of 2 times of Z1, 3 times of Z2 plus 4 times of Z3 is equals to 4, then we just need to calculate the value of the value of 8 times of Z2 Z3 plus 27 times of Z1 Z3 plus 64 times of Z1 Z2. In this question we have mod of Z1 is equal to 2, mod of Z2 is equal to 3, and mod of Z3 is equal to 4, and mod of 2 times of Z1 plus 3 times of Z2 plus 4 times of Z3 is equal to 4. Then we just need to calculate the value of mod of 8 times of Z2 Z3 plus 27 times of Z1 Z3 plus 64 times of Z1 Z2. Guys, try to solve. Aditya, very good, excellent beta. Very good, Aditya. Guys, please everyone try to solve this question. Very good, Ayushi. Okay, alright guys. So guys, in this term we have mod of z1 as 2, mod of z2 as 3 and mod of z3 is equal to 4. And we have mod of 2 times of z1 plus 3 times of z2 plus 4 times of z3 is equal to 4. Then we just need to calculate the value of this term. So now guys, please listen very carefully. We have z2, z3, z1, z3 and z1, z2. If we multiply by z1, z2, z3 and divide it by z1, z2, z3, then we have mod of z1, z2, z3 and multiply by. First term will convert into 8 upon z1, then after 27 upon z2 and then after 64 upon z3. First term we have mod of z1, z2, if we multiply by z1, z2, z3 and divide it by z1, z2, z3, then we have z1, z2, z3 multiply by 8 upon z1 plus 27 upon z2 plus 64 upon z3. Now, we have mod of z1 is equal to 2. We can also conclude this term as mod of z1 square is equals to 4. If mod of z1 square is equal to 4, then z1 multiplied by conjugate of z1 is equal to 4. Now we can say that z1 will be equals to 4 upon conjugate of z1. And similarly, if we calculate for z2, then z2 will be equals to 9 upon conjugate of z2 and z3 will be equals to 16 upon conjugate of z3. Now, if we substitute these values on this term, or you can also say that conjugate of z1 will be equals to 4 upon this and conjugate of z1 will be 9 upon this and conjugate of z3 will be 16 upon this. If we substitute this term in this equation, then we have z1, z2, z3 and then 8 upon z1 will definitely equals to 2 times of conjugate of z1. 27 upon z2 will definitely equals to 3 times of conjugate of z2 and the last term will definitely equals to 4 times of conjugate of z3. Now if we calculate this term, then we have mod of z1, z2, z3 multiplied by this, so we can also write this as mod of z1, mod of z2, mod of z3 and multiply by mod of 2 times of conjugate of z1, 3 times of conjugate of z2 and 4 times of conjugate of z3. Now according to the property, if we have conjugate of z1 plus z2, that will definitely equals to conjugate of z1 plus conjugate of z2. It means we can also write this term as mod of z1, mod of z2, mod of z3 and multiply by mod of 2z1, 3z2 plus 4z3 and conjugate of this complete term. Now again we all know that mod of z is equals to mod of conjugate of z. So now we can say that mod of z1, mod of z2, mod of z3 and multiply by mod of 2z1 plus 3z2 plus 4z3. We have mod of z1, mod of z2, mod of z3 and multiply by mod of 2z1 plus 3z2 plus 4z3. Now if you want to calculate the value of mod of z1, then mod of z1 is equal to 2, mod of z2 is equal to 3, mod of z3 is equal to 4 and this term is definitely equals to 4. So the answer will be 2 multiplied by 3 multiplied by 4 multiplied by 4 which is equals to 96. Yeah, very good Aditya. So 96 is the correct answer. ये क्वेश्चन अब तक आईआईटी में 2 बार पूछा हुआ है. So guys, if you have any kind of doubt or query related to this term, you can ask. If you have any kind of doubt or query related to this term, you can ask. Kunal, pata hai what's the meaning of O? O means yes or no? आयुषी बेटा डायरेक्टली कैसे वैल्यू सब्स्टिट्यूट कर देंगे हम? We have mod of z1 as 2, not z1 is equal to 2. Tirupati, in the second step, we have 8 upon z1. We can also write this term as 2 times of 4 upon z1. And 4 upon z1 will definitely equals to conjugate of z1. Similarly, we can also write this 27 upon z2 as 3 times of 9 upon z2. 9 upon z2 will definitely equals to conjugate of z2 and so on. Yeah, Praveen. We can write this term as, if we have k times of z, we can also write this as, if we have mod of kz, then we can also write this as k times of mod of z. Or you can also consider this as k as a complex number, purely real complex number. Or as we all know that if we have mod of z1 multiplied by z2, then it will definitely equals to mod of z1 multiplied by mod of z2. Guys, is it clear for all? Or if you have any kind of doubt, you can ask. No, we only have a single method for this question. We only have a single method for this question. Okay, all right. So the next question is, okay, just leave it. So the next term is, Praveen, then how is second statement of question? Praveen, why? We have mod of 2z1 plus 3z2 plus 4z3 as 4. Okay, all right. Praveen beta, according to the triangular inequality, we have mod of z1 minus of mod of z2 is less than or equal to mod of z1 plus z2. It means if you want to talk about the minimum value of mod of z1 plus z2, then it is always equals to mod of z1 minus mod of z2. So no need to consider positive everywhere. Beta, if suppose we have a complex number z as x plus iota y. Now if you want to calculate mod of z, then this will definitely equals to square root of x square plus y square. Now we have conjugate of z as x minus of iota y. Now if you want to calculate mod of conjugate of z, that will be definitely equals to x square plus iota y, x square plus y square. So now we can conclude this as mod of z is equals to mod of conjugate of z. That's why I removed the sign of conjugate in the last step. Guys, now is it clear? Praveen, is it clear? Two times of mod of Z1 plus 3 times of mod of Z2 plus 4 times of mod of Z3 will be the maximum value, not minimum value. But beta, how can we write this? Mod of Z1 plus Z2 is not equal to mod of Z1 plus mod of Z2. ये तो तुमने कंसेप्ट्स की बैंड बजा दी सभी की। प्रवीण बेटा, इट इज नॉट पॉसिबल। Mod of 2Z1 plus 3Z2 plus 4Z3, maximum value of this term will definitely equals to 2 times of mod of Z1 plus 3 times of mod of Z2 plus 4 times of mod of Z3. Guys, now is it clear? Praveen, is it clear now? Okay, all right guys, then after we have rotation of complex number. Then after we have rotation of complex number. So now guys, please listen very carefully and try to link all these terms with a simple basic geometry. Suppose we have two complex numbers. First one is Z1. We can write this as r e to the power iota theta, or you can also write this as mod of Z1 e to the power iota theta 1. Now the second complex number is Z2. Let's consider Z2 is equals to mod of Z2 and e to the power iota theta 2. First one is mod of Z1 is first complex number Z1 is mod of Z1 e to the power iota theta 1, and the second complex number Z2 is mod of Z2 and e to the power iota theta 2. Now if we draw these two complex numbers on the Argand plane, suppose we have Z1 here and the Z2 here. If we join these two terms with the origin, then we have this angle as theta 2 and this angle as theta 1. This distance will be equals to mod of Z1 and this distance will be equals to mod of Z2. Now if we divide these two terms, then we have Z1 upon Z2 is equals to mod of Z1 upon mod of Z2 and e to the power iota theta 1 minus theta 2. Because as we all know that if we have e to the power iota theta 1 divided by e to the power iota theta 2, that will definitely equals to e to the power iota theta 1 minus of theta 2. So now we can also write this term as Z1 minus of 0 divided by Z2 minus of 0, which is equals to mod of Z1 minus 0 upon mod of Z2 minus of 0 and e to the power iota theta 1 minus of theta 2. Let's consider theta 1 minus of theta 2 as theta. Let's consider theta 1 minus of theta 2 as theta. So we can also write this term as e to the power iota theta. It means the angle between these two terms will definitely equals to theta. Now we can also conclude this term as if we rotate Z2 about origin, in anti-clockwise direction for theta angle, then the final complex number will be equals to Z1. If we rotate Z2 about origin in anti-clockwise direction by theta angle, then we have final complex numbers as Z1. So the thing is, we just need to remember this formula in this manner only. We have final upon initial. If we talk about the final, we have Z1 minus 0. If we talk about the initial, then we have Z2 minus of 0, which is always equals to magnitude of final upon magnitude of initial and e to the power iota theta, where theta is angle in anti-clockwise direction, or you can say angle between Z1 and Z2 in anti-clockwise direction. Now we can clearly say that final upon initial is equals to magnitude of final upon magnitude of initial and e to the power iota theta. Now suppose we have two different complex numbers z1 and z2, and if we want to rotate about the z3, theta angle in anti-clockwise direction. So initially we have z1, finally we have z2. If we rotate z1 about z3 in anti-clockwise direction, then we have finally final complex number as z2. So we can clearly say that, or you can say we can clearly write this term as final upon initial. Final is z2 minus z3 upon initial is z1 minus of z3. Final is z2 minus z3 upon initial is z1 minus z3, which is equals to magnitude of final upon magnitude of initial and e to the power iota theta. So guys, please remember this formula only in this manner: final upon initial, which is equals to magnitude of final upon magnitude of initial and e to the power iota theta. So guys, please note it down, or if you have any kind of doubt or query, you can ask. If you have any kind of doubt or query related to these terms, you can ask. Very good, Tirupati. Okay, all right, guys. Okay, all right. Suppose guys, we have a square whose point of intersection of diagonals as 0, 0, and one vertex is given as z1. One vertex is given as z1. So we can clearly say that if we rotate this z1 about origin in anti-clockwise direction by 90 degree, or you can say pi by 2 angle, then we have the then we have the final complex number, or you can say then we have a second vertex. So now initial is z1 minus 0 upon final is z2 minus 0, which is equals to magnitude of initial upon magnitude of final and e to the power iota pi by 2. We have final upon initial, which is equals to magnitude of final upon magnitude of initial and e to the power iota pi by 2. Now we can also say that z1 will definitely equals to z2. Sorry. We just need to write final upon initial, not initial upon final. We just need to write final upon initial. Final is z2 minus 0, initial is z1 minus 0, magnitude of final upon magnitude of initial and e to the power iota pi by 2. Now we can clearly say that mod of z1 will definitely equals to mod of z2, so this term will equals to 1. So now z2 will be equals to z1 e to the power iota pi by 2, which is equals to cos pi by 2 plus iota sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1. It means we can clearly say that that term will be equals to z1 multiplied by iota. It means if we rotate any complex number about origin in anti-clockwise direction by 90 degree, then the final complex number will be equals to z1 multiplied by iota. We just need to multiply by iota, that's it. Now again, if we rotate this term about origin in anti-clockwise direction by 90 degree, then we have this complex number as minus of z1, because z1 iota multiplied by iota is minus of z1. Again, if we rotate this complex number by 90 degree in anti-clockwise direction, then we have this vertex, and this vertex will be equals to minus z1 multiplied by iota. Guys, is it clear for all? Okay, all right. So the question related to this concept is, we have a triangle whose vertices are Z1, or you can say Z1, iota Z1 and Z1 plus iota Z1. We have three vertices of triangles are Z1, iota Z1 and Z1 plus iota Z1, and area of triangle is equal to 8. Then we just need to calculate mod of Z1. And area of triangle is equals to 8. Then we just need to calculate mod of Z1. Tirupati beta, because mod of Z1 is equals to mod of Z2. It's a square. It means in the square diagonals bisect each other and the length of diagonals are also equals. That's why mod of Z1 is equal to mod of Z2. If we calculate mod of Z1 divided by mod of Z2, this will definitely equals to 1. Okay, so now guys, try to solve this question, everyone. In this term we have three vertices of triangle. First one is Z1, second one is iota Z1, third one is Z1 plus iota Z1, and area of triangle is equals to 8. Then we just need to calculate mod of Z1. Let's see सबसे पहले किसका करेक्ट आंसर आता है. Very good, Praful Aditya. Very good, guys. Praveen, very good. Sidhu, very good. Guys, please everyone try to solve this question. It's a very simple question. Very good, Ashwin Raghav. Okay, all right, guys. So in this term, in this question, if we draw the diagram of this triangle, or you can say if you mark the vertices of triangle, then we have y-axis, x-axis. First we have z1, if we multiply by z1 with iota, then we have iota times of z1. It means this angle will definitely equals to 90 degree. Now according to the vector, if we substitute this term from here, then this vector will definitely equals to iota times of z1. Now this term is z1, this term is iota z1, then this vector will definitely equals to z1 plus iota times of z1. So it means this vertex will represent z1 plus iota z1. Now if we join these terms, then we clearly say that we have a triangle like this. One vertex is z1, another is iota z1, and another is z1 plus iota z1. This term is equals to mod of z. It means this is also equals to mod of z1. This term is definitely equals to mod of z1. It means this will also equals to mod of z1. Because if we calculate mod of iota z1, this is also equals to mod of z1. Then after, this angle is 90 degrees, so this will also equals to 90 degree. Now we can simply say that it's a right angle triangle whose base is mod of z1 and the perpendicular is also mod of z1. So the area of triangle will be equals to half base multiplied by height, which is equals to 8. It means mod of z1 square is equal to 16. Then mod of z1 will definitely equals to 4. So the final answer is equals to 4. Guys, is it clear for all? First we have z1, then after we have iota z1. We can replace any vector which is parallel to this. So if we replace iota z1 here, then we have z1 iota z1. If this vector is z1, this is iota z1, then this will represent z1 plus iota z1. So now we can clearly say that we have z1 iota z1, then after z1 plus iota z1. If this angle is 90 degree, this will again this will also equals to 90 degree. And if this term is mod of z1, this is also mod of z1. If this term is iota z1, then this will equals to mod of iota z1, which is also equals to mod of z1. So we have mod of z1 and a right angle triangle. So the area will be equals to half base multiplied by height, which is equals to 8. So now z1 square is equals to 16. It means z1 will be equals to 4. Guys, is it clear? Okay, all right. Then after we have a cube root of unity. Then after we have cube root of unity. It means suppose we have an equation like x cube is equals to 1. Then we have a cubic equation. It means we have three different roots in which one is real or two may be real or imaginary. So one is definitely real, because we can clearly say that if we put x is equal to 1, then 1 is definitely equals to 1. It means x is equals to 1 will definitely a root of this equation. Now we can also say that we have x cube is equals to 1. It means x cube minus 1 definitely equals to 0. We can also write this term as x cube minus 1 to the power 3 is equals to 0. Now we can use the formula of a cube minus of b cube. This will equals to a minus of b and a square plus b square plus ab, which is equals to 0. So we have two different possibilities. First possibility is x minus 1 is equal to 0. It means x will definitely equals to 1. And the second possibility is x square plus x plus 1 is equals to 0. Now if we calculate the root, then we have x will be equals to minus of 1 plus minus root 3 iota minus 1 plus minus iota root 3 divided by 2. So the first term we have is x is equals to minus 1 plus iota root 3 divided by 2, and the second term we have as minus 1 minus iota root 3 divided by 2. So guys, first we have x cube is equal to 1, then after we have x cube minus 1 is equal to 0. So we can also write 1 as 1 cube. So we have a cube minus of b cube, which is equals to a minus of b, a square plus b square plus ab, which is equal to 0. It means we have two different possibilities. First one is x minus 1 is equal to 0, it means x is equal to 1. And the second one is x square plus x plus 1 is equal to 0, it means x will be equals to minus 1 plus minus iota root 3 divided by 2. So now we have x as minus 1 plus iota root 3 by 2 and minus 1 minus of iota root 3 by 2. Now if we call this term as omega, if we call this term as omega, it means यानी हमने इसको एक नाम दे दिया omega. Now if we square this term, if we take square this term, then we have minus 1 minus of iota root 3 divided by 2. Now we can say that this term will definitely equals to omega square. If we consider first term as omega, यानी हमने इसको एक नाम दे दिया omega, so it means if we take square of this term, then we have minus 1 minus iota root 3 divided by 2. It means this term will definitely equals to omega square. Now we have omega as minus 1 plus iota root 3 divided by 2. We can also write this term as minus 1 upon 2 plus iota times of root 3 by 2. Now we can as we all know that cos of 2 pi by 3 is equals to minus 1 by 2 and sin 2 pi by 3 is equals to root 3 by 2. Cos of 2 pi by 3 is equals to minus half and the sin 2 pi by 3 is equal to root 3 by 2, and cos theta plus iota sin theta will definitely equals to e to the power iota theta. So this term will equals to e to the power iota multiply by 2 pi by 3. Now if we consider the second term, then we have omega square as minus 1 upon 2 minus iota root 3 by 2. So we can write this term as cos of 4 pi by 3 plus iota times of sin 4 pi by 3. Now we can also write this term as e to the power iota 4 pi by 3. So the first omega is equals to e to the power iota 2 pi by 3 and the omega square is equals to e to the power iota 4 pi by 3. So now we can also write this as omega is equals to e to the power iota 2 pi by 3 and omega square is equals to e to the power iota 4 pi by 3. After this we have some other relations also. We have x cube minus 1 is equal to 0. We can also write this equation as x cube plus 0x square plus 0 times of x minus 1 is equal to 0. Now we can clearly say that sum of the roots will be equals to 0 and the product of the roots will be equals to 1. It means 1 plus omega square is equals to 0, or you can simply say that sum of 3 consecutive powers of omega is always equals to 0. It means omega to the power k plus omega to the power k plus 1 plus omega to the power k plus 2 will definitely equals to 0. Sum of 3 consecutive power of omega is always equals to 0. Then after product of the roots is equals to 1. It means 1 multiplied by omega square, it means omega cube. So omega cube is equals to 1. Now we can say that omega to the power multiple of 3 is always equals to 1. If we have omega cube, omega to the power 6, omega to the power 9, all terms are always equals to 1. So guys, please note it down, or if you have any kind of doubt or query related to this omega, you can ask. Guys, please note it down, or if you have any kind of doubt or query related to the omega, you can ask. So we just need to remember two things. Sum of 3 consecutive power of omega is always equals to 0, and the next one is if you have omega to the power multiple of 3, then it will definitely equals to 1. आदित्य बेटा हमारे डाउट्स आ रहे हैं ना, इससे पढ़ाई से रिलेटेड नहीं होते। हाँ कल क्लास होगी तुम्हारी, कल तुम्हारी डाउट क्लास होगी, और इवन जो भी डिसाइड होगा वो तुम्हारे पास मैसेज आ जाएगा। नो टेंशन लेने की जरूरत नहीं है, जब क्लास होगी उससे पहले तुम्हें इन्फॉर्म कर दिया जाएगा। Guys, please note it down, or if you have any kind of doubt or query, you can ask. Okay, all right, guys. This is all about the today's session. In next session, we will discuss about the nth root of unity. Then after, we will discuss few more concepts of complex number. Beta, we have x cube is equals to 1. We can also write this term as x cube minus 1 is equal to 0. 1 is also equals to 1 cube. So now apply the formula a cube minus b cube, simple. Okay, all right guys, thank you so much, thank you again. मिलते हैं फिर अब हम नेक्स्ट सेशन में। नेक्स्ट सेशन में इसी के आगे कंटिन्यू करेंगे, और कुछ कंसेप्ट्स रहते हैं, देन वी विल डिस्कस सम फ्यू कंसेप्ट्स ऑफ कॉम्प्लेक्स नंबर, और यू कैन से लोकस ऑफ कॉम्प्लेक्स नंबर। सो अगेन थैंक यू, मिलते हैं फिर अब हम नेक्स्ट सेशन में।